Hello everybody. Today we will discuss problem number 2 from US Physics Olympiad year 2009 USAPHO Quarterfinal. So problem. A ball of mass m is thrown vertically upward with the speed of v0. The ball is subject to an air resistance force that is proportional to the velocity, F equal negative kV. The ball rises up to height of h and then returns to the starting point after some total time tf. The acceleration of free fall is g. Determine the following. A. An expression for the velocity as a function of time in terms of any or all of the constants. B. Sketch the graph of velocity versus time. On the sketch, indicate the time to rise to the highest point tr and the total time of flight tf. You do not need to find either tr or tf at this point, but your graph should reflect relative positions of both. C. Find the time to rise tr to the highest point h in terms of any or all of the constants. Solution. First, let's write the equation for motion in this condition, because we already know that force of resistance proportional to velocity. So this equation looks like this. If we have vertical up direction is positive, we have such equation that ma equal negative mg, that's force of gravity, minus kv, so that's the negative direction to velocity. Let's rewrite it in form of a differential equation. We have first derivative from velocity by time, that's equal this expression as a function of velocity. It means that we can split variables and rewrite it in form of. Now we can do integral for both parts, and that will be answer. When we integrate from velocity v0 to some kind of velocity v, and the time is going from 0 to t. So after integration we have this expression, or velocity equals this expression. Now let's check what do we have here. When t is going to infinity, we have v is going to negative mg over k. That will be terminal speed, and we can call mg over k terminal speed, like this. V terminal equal mg over k, and in this case we can rewrite this equation as this one. So that's answer for question A. Now we can sketch the graph for velocity versus time. Let's say we take terminal speed, that's about 60 meters per second, and initial speed at 30 meters per second up. So for this condition we can draw this graph. This is our graph, velocity versus time. So here we have initial velocity about 30 meters per second, and terminal velocity is 60 seconds. Velocity is going to 0 when time is going to a little less than 3 seconds. Yes, that's correct. That's approximately answer for question B. And now we can estimate what is total time. T, F, just counting what is the area under the graph. So that will be this, and probably here we have, in this point, we have point TF when it's reach height equals 0. And the last question, find the time of rise to the highest point H in terms of any of all constants. Let's do this. We have to solve this equation when v equals 0. And if we put here v equals 0, we will get answer like this. TR equal v terminal over g multiplied by logarithm from 1 plus v0 over v terminal. And now we can find what is total height h. We just need to integrate this expression, and the integral will be from 0 to h, and here from 0 to tr. Let's do this. This is our calculation. We have height h equal integral from 0 to tr from this expression, which will give us this expression. But tr is known, is this one. So we can insert this tr here and calculate what is the final result. That will be this one. V terminal equal this one. And now let's see what happens if we have terminal speed is infinity. So when there are no resistance from air. In that case, we can represent logarithm in form of for small this argument that will be x minus x squared over 2. When we multiply this, we will get a regular expression v0 squared over 2g. So that's the total solution.